So we're antiderivatives. We're gonna get into something called the initial value. Okay. These are generally going to come at you in the form of word problems. Okay. I'm going to show you a couple of calculation problems, and then I'm going to start. We're going to look at some particle motion problems, just so you kind of get the hang of calculating these stuff. Basically, what we're doing is getting rid of the constant c. Okay, at this point. So you're gonna run into problems. They're gonna be worded like you haven't seen before. So you might see solve dy dx equals 4x to the 7th, which y of 0 equal to 4. If you're looking at a derivative and it says solve, what that's going to mean for us is that we need to calculate y equals. Okay. So how can I calculate that from a derivative? Yeah. Antiderivative. Okay. So start with the derivative. Antiderivative gets you back to the original, right? This will be a very common thread the rest of the quarter until spring break and a little bit after. So, okay. Right. So y equals x to the 8th over 2 plus some constant. Right? Is it 4? How do you know that? It's a guess? It's a poor guess. It's actually a good guess, but yeah. Yeah. You have an x and a y here, right? Plug 0 in, plug 4 in, solve for a constant. So 4 equals our constant. Right. So basically what we have here is this initial condition is telling us where to place our function on the axes, the graph of it. Okay. So officially y equals x to the 8th over 2 plus 0. I'm going to show you one more calculation problem with sine. Do you understand why there's a constant? Okay. Let's solve the initial value problem. You mean it's flickering? I've been maxing out my computer, so it's get more memory. It's not my computer, or it would have more memory. Okay, notice we're using t here, not a big deal. Remember, when you're deriving with respect to t, you want that to match or we have implicit differentiation. But in this case, we're good. So, you're close. Okay. There's something here that we need. We need a plus c, and don't forget, because that's a pi t, we have to divide by that number. Right? It's that chain rule, antiderivative chain rule. Okay. Now, again, you can check your work. If you calculate the derivative of this function, you should get back to the original, right? So if you want to include that in your work, you can. So, that's where we're at. It's my y value, Danielle. 2, and my x value, 2. Haha, trick question. The t value is 2. Don't worry about it. Cosine 2 pi, quick, no calculator. This will be a no calculator problem, I guarantee it. It's the same as cosine 0. 1, because cosine starts at 1. So 2 equals negative 1 over pi plus c. And what is our constant then? This is a no calculator problem. Think about, all you do is add 1 over pi, and you're done. We don't need decimals. Mathematicians are very happy with an exact answer, right? Because you do a decimal, not exact anymore. What's my function, Canyon? What's my dysfunction? For the math teacher, okay, what's the function I need to write to finish this problem? That's it. Don't make it more complicated than it needs to be. Okay. Just take this and plug it in. Yeah, fine. You know I'm going to.
Can we just like stop here?
Are you okay with this? Okay. Here's a word problem.
Ah.
There will be one like this on the quiz. It's in. say we have a car traveling at a velocity of 24 meters per second, begins to slow down. It stopped on the train tracks at time t equal to 0 with a constant deceleration well, I erased that it was there of there's your problem statement, right? Okay. Find the velocity v of t at time t of what? So we have position.
So we have given the acceleration with AFT.
Yeah. So remember your position, velocity, acceleration, right? Derivatives of each other. Starting.
So we have to bring the acceleration to the velocity, so like the antiderivative of the second derivative.
You're given the acceleration function, we have to go back to the velocity, so we're doing antiderivatives here. And so we need to calculate the integral of -6. It's just a number. Yeah. Not quite. There you go. Okay. Not quite. We'll add that in there. So, you with me? I can hear rocks rattle. I'll let you stop writing. What? Well, fill yourself up with oil. Need a lubricant.
T equals 0, so we have to plug in
So,
times 0.
yeah, what's my initial value? And that's my t value, right? Yeah, right there. There's your initial value. It's kind of hidden in the word problem there. It's really the only other information we have. So what's C? Man, these are easy. They're not always going to be that easy.
Well, it's supposed to be that easy. I don't like that answer.
We discussed rocket science this morning with Calvin. Integral of, we did integrals at infinity, so we have antiderivatives out to the infinite. Okay, so are we okay with calculating that velocity function?
Yeah.
Yeah. So yeah, keep in mind this relationship. Now we can go forwards and backwards. All right, second part here. Calculate the distance traveled before the car comes to a halt. There's a little bit to this question. Okay. Some things that might pop in your head. How long did the car travel? Do we know that? So what do we need to find? We need to calculate for how much time. Okay, that's kind of embedded in here, right? How can we figure that out? Say that again. Setting the velocity equal to 0 will tell us when this car comes to a halt. So if the velocity function is negative 6t plus 24, right? Make sure. Yep. T is 4. So we need to go from t equals 0 to t equals 4, right? What else does we know? It's a position question. Okay. Ooh, there it is. Favorite word. Bug. I haven't been able to pull that one out in a while. So it makes me giggle. Am I getting to you? I love it. You didn't go that far, did you? You guys all write fun? FUN capitals? No? Okay. Oh, that's good. That makes me smile. Thank you, guys. What's the position function? Okay. I anti-differentiate velocity to get position, right? So it's negative 6t squared over 2, which is negative 3t squared, right? How do I get rid of that? So I know times 0, what's my position going to be? We can assume it's 0. It'll make it a lot easier to calculate time forward. So if you plug 0 in here, what's constant going to be? Yeah, we can assume the constant is 0. Lots of different ways to explain that. So we're going to assume that the initial position is 0. That makes our calculation really easy. So that means that the constant is 0. S of 0 equals 0. We're forcing our starting point to 0, so it's not an easy subtraction problem. The only other item we need is the position at 4, which is physics.
She said we weren't at all very good at math. Yeah, especially advanced students. She said we were all going to fail the essay. Are you kidding me?
She doesn't like us.
Yeah, she went in on that.
Well, why? Like, she put her homework first.
It's not because it's just she doesn't like math or math because we tried it. That's okay. But okay, so focusing back here, let's stop complaining about lit because that's not what we're about here. We know the truth, right? The truth set this free. The position at 4 is 48 meters. Yes? My position at 0 is 0 meters. How far did I travel? Yeah. Because this is in meters. So probably.
Why can I say that S of 0 is 0?
Oh, okay.
Why can we assume?
Yeah, why can I? Is it because like 3 times t squared plus 40
It really doesn't matter where you start. If I get a different, so what if this was 10?
Also,
Right. I would have a plus 10 here, but then I would subtract it out anyway.
Okay.
Right?
Yeah.
So it doesn't matter. The car traveled. Okay, this is a problem statement you're going to need to get used to writing. Okay, the car travel is the subject of the statement, yes. Include it. 48 meters, include your units. You might get a point for that. From time t equals 0 to time t equals 4 seconds.
Probably safer just to wait it.
Okay, one of the, at least 2 of the AP problems over here says explain your answer in context of the problem. This is your mathematical answer. Is that in context? It just says 48. You need to be able to say 48, oh, I know what that is. You're actually applying it out here. The car traveled 48 meters. That's explaining your context. It's not very hard. It's easy points. Sometimes they even give you a point for putting that right there. Bonus. 4 meters. Any questions? What's the question? Will be straightforward. number 71 from the first day of this section, you do not be able to do that problem. If you want more practice, you could do that. It's not required, but these I wrote down a couple days ago.
Do you mean an AP2 number 3 and for the FRQ?
No, multiple choice.
So everything is multiple choice? Oh, okay, because I thought we should do the FRQ problems.
We already have.
Oh, okay. But AP, in AP2. Okay.
We've gone through those ones already.
Oh, okay.
We've actually done these before.
Yeah. Yeah, that's why I
Wait a
wanted
couple
to say
months, we cycle them to see.